All right, so using variables, 1-2. Using variables. Well, first of all, let's establish what is a variable. Josiah? Sure. A letter that takes the place of a number or a value, if we want to say it like that. In algebra, we often translate verbal expressions into mathematical expressions. Consider the following sentence. J has $2 more than K. Now, if we thought logically about it, and I told you J has $2 more than K, if I told you K had $10, how many dollars would J have? Right. So logically, we can think those things through, and they make sense. And I ask you to do that because once you have to use variables, it's helpful to know how to put it in perspective so that you can check the work after you're done. You know he's having $2 more. Does that still ring true after you plug in the values into your little sentence? Okay. From the information given, you do not know exactly how much money J has nor how much K has. You can, however, use variables to represent the amount that each person has. So if J has $6, then K has 6 minus $2, which makes it 4. Is it still $2 less than what he had? Yeah. If he has 10, then she has 10 minus 2. Or if J has J dollars, then K has J minus 2. J could be anything. He could have $100. He could have $1 million. We don't know. All we know is that K has $2 less than that. Can he have $0? Is it possible to have negative $2? Dead is one way of looking at it, absolutely. Okay. The amounts above are expressed in terms of the amount J has. What do you think in terms of the amount that K has? So since you're talking about two different things and two different people, we use subtraction as our primary operation when we said J had this much, and we had to take 2 away to find out how much K had. Remember the relationship? J had 12, where K had 10. It was always $2 less. So if I knew how much J had, I was subtracting 2 every time to find out how much K had. Now the opposite is true. If I know how much K has, if I say K has $16, then how much does J have? 18. Did we subtract there? We added, because now we're talking about a different value altogether. Now the constant is still 2. It's just what we do with it that changes. Okay? But again, you told me right away what that relationship was based on what we knew. You just have to be willing to take a look at it. So we knew J, right? To find out. So I could make my own equation for this. J minus what? 2 equals K. See why they use J and K? So J minus 2 equals K. Did we come up, did we use variables here? And no matter what we plug in, either for J or K, that would work. Going the opposite way, if I knew how much K had, K plus 2 equals J. Are these the same? What is, you don't have Spanish today, but what's the Spanish word for water? Agua. Agua, good. You didn't say uno, did you? For water? ¿Qué? ¿Cómo? I said water, didn't I? No, you said water. Well, you can listen to the playback later. All right. Are these the same? Is this the same? Is 1 in English is to uno in Spanish, just like water in English is to agua in Spanish. It's saying the same thing, but just in a slightly different language. Are these two equations up here saying the same thing, except in just a slightly different language? Absolutely. Could I use either one of those to find out a missing value for either how much J has or how much K has? Sure I could. Either way. It's just a matter of preference. If you know the value for J, you might want to use this one. Why? Because K is already by itself on one side of the equal sign. Could you find K if you use this one? If you plugged it in and you knew J had $18, could you still find out how much K had? Yeah. I mean, both of them will work. It's just a matter of setting them up and doing what you can with it, okay? Now let's take a look down at the bottom in that box if you have the book open. If you don't, just listen. You should be able to figure it out pretty easily. In algebra, we often use a variable to represent an unknown quantity. A letter may be used as a variable. Here are some helpful hints when they put the expressions into words, what operations they represent. 3 more than a number. More than always represents addition. 6 less than some number. Less than always means some number increased by 4. Addition. Decrease means the sum, S-U-M. What about addition? The sum specifically refers to what? Right. The answer when you add. And the some number less 9 is K minus 9. Okay, so order does matter in a lot of cases. Just making sure you double check that before you make it final. Let's go through some scenarios here. I'm going to put this on the board. Let's say that I've got some values for some variables. When I see a letter A, I know it's going to equal 2. When I see a letter B, I know it's going to equal 5. When I see a C, it's going to equal 10. So I'm going to give you some equations, and I want you to kind of do these on your own. You know the value for the variables. Number 1, A plus B. Well, if A is 2 and B is 5, we should get 7. A plus B plus C. C is 10. 17. Again, A, B, 13. 20, you said? And C minus B, 10. Very good. How many of you had all 4 of them? Awesome. So it's just a matter of substituting. Example 2 at the top says evaluate A plus K if A is 11 and K is 14. Same thing. Okay. Does A always equal 2? No, just like it doesn't always equal 1 or 14 or 57 or whatever. Okay. Oftentimes it'll change. It'll vary, right? So let's take a look at the exploratory section, 1 through 20. And let's see if we can come up with some real basic algebraic expressions based on what's written in words there. So number 1 says 5 more than y. How would I write number 1? 5 more than y. Cal. Y. 5 more than y. Okay. Y plus 5. Number 2, the sum of y and 2. The sum of y and 2. Right? 3, 8 less than w. If, pay attention, if for number 1 followed the pattern that 5 more than y was y plus 5, then how are we going to fill in 8 less than w? Really? Good. W minus eighths. Number 4, P decreased by 3. Caleb? P minus 3. Number 5, 8 increased by M. 8 increased by M. 8 increased by M. 8 increased by M. If I said this to you, if I took out M altogether, I said 8 was increased by 2. Would that be a little bit easier to comprehend? If I said 8 increased by 2. We had 8, our number was 8, it increased by 2. We added 2 onto that. Okay? Now, some of you might be saying, okay, well, for this one, does the order really matter? Well, yes and no. Because it's addition, no matter what you would put in for the variables, it's not going to affect what your solution would be, your answer would be. But it's a good habit to get into, because does the order matter with these? Absolutely. So when I said yesterday about learning the language, this is all kind of like learning the language, learning how to decipher the stuff. Okay? Don't be frustrated by it. Try not to be confused by it. It's just a different way of looking at things. Okay? 6, the sum of A and B. A plus B. Okay, 7, 5 less than a number. Yeah. 5 less than a number. You're going to have a number, and you're going to go 5 less than that. Uh, 5 less than a number. Not a number less than 5. T minus 5. Again, it's that crazy language again. Okay, but it matters. It makes a difference, trust me. Okay. How about number 13? 4 increased by a number. 4 increased by a number. When they don't give you a specific variable, but they use number, I just usually use n, but you can use whatever you want. You can use d, you can use y. Austin. Good. Now we'll do some more, but I'm going to make page 7, numbers 22 to 44 even, your assignment. Now notice at the top of that section, evaluate if A is equal to 6, K is equal to 8, M is equal to 5, P is equal to 7, and S is equal to 11. If I were doing this, what would you recommend that I do? I might want to write that somewhere at the top so I don't lose track of it. Otherwise, you have to keep looking back, and that's when mistakes happen. Okay? So your algebra portion of your assignment for tomorrow is page 7, numbers 22 to 44 even. Okay? Where are we at? I'm going to give you about 10 minutes to get this part started. Then we're going to get into the next part.